Hi, in this video we're going to look at how we go about solving equations with three variables. Now, when you started out solving equations, you'd have solved an equation with one variable in it. Might be in something simple like this. Let's say it was 2x minus 5 equals 25. Well, we'd have gone through the usual process. We would have added 5 to both sides, and we'd have got 2x is equal to 30, and then we'd have divided both sides by 2, and we've got that x is equal to 15. And we would have one solution. We've got this one solution, and the equation, when we started out, had only one variable. So there's a link there between the number of solutions and the number of variables we got. A little bit later on, we took that a little bit further for you, and we introduced the notion of two variables in an equation. So we might have given you something like this, and we said, okay, well, we've got an equation that says x plus y is equal to 10. Now, there are a whole host of possible solutions we could have with that. But we also classified to say, okay, well, we also want to know, or we also tell you that x minus y is equal to 8. And now, what are the values of x and y that will satisfy those two equations? Well, this is what you would know as a simultaneous equation. You most would have done something like this. We'd have looked at calling the first equation A, the second equation B, and then we'd most would have said, okay, well, in order to solve this, I'm going to say A plus B, and then I can just add those two lines together. I'll have 2x is equal to 18, and in the process I've eliminated one of the variables, and so I can now say that x is equal to 9. And if we've got x equal to 9, well, I can just sub x is equal to 9 back into either of the equations, either equation A or equation B. I'm going to take equation, no, I won't take equation B, I'll take equation A. Into equation A, and we will have 9 plus y equals 10. And so I think it's fairly straightforward to see that y has to equal 1. So I've got two solutions here. I've got the solution that x is equal to 9, and I've got the solution that y is equal to 1. Those two values will satisfy those two equations that we've got over there. So two variables, if I want to find out what their particular values are, I need to have at least two equations. And so we now move on to the part that we're going to work with here, and that is to say, right, what happens when I have three variables? How am I going to go about solving that? Well, let's take these three equations. We've got x plus y plus 2z equals 6. I've got 2x plus 3y plus 5z equals 10, and I've got 3x plus 7y plus 7z equals 1. I can call that equation A, I'm going to call that equation B, and I'm going to call that equation C. Now, if you've got a graphics calculator, you can go and solve that straight away on a graphics calculator, but the course that you're doing is an algebraic-based course, and so we need to see how we can go about solving this algebraically. Well, to start off with, I'm going to try and eliminate one of the variables. So I'm going to take equation B, and from it I'm going to subtract two lots of A. So in other words, I'm going to have my B equation, which is 2x plus 3y plus 5z equaling 10. And two lots of equation A will be minus 2x minus 2y minus 4z, and that's going to equal minus 12. And so when I put all of those together, I'm going to come up with y plus z is equal to minus 2. So I've eliminated the x's, but I've got two variables left over. I'm going to have to call this equation D. Now I need to take another pair of equations and try and eliminate something from there as well. So this time I'm going to take equation C, and from it I'm going to subtract 3 lots of equation A. Equation C looks like this: 3x plus 7y plus 7z equals 1. And 3 lots of A will be minus 3x minus 3y minus 6z is equal to minus 18. Now if I go and add those two together, my x's are going to go. I'm going to be left with 4y plus z is equal to minus 17. So I've got a second equation now with two variables in it. And now we get back to the situation that we had before. Two unknowns, two equations. So I'm going to have to work with those two equations. I'll just write them again over here. Y plus z equals minus 2, and 4y plus z equals minus 17. Okay, that's equation D, that's equation E. And in this situation, I'm going to say equation E minus equation D. And what will I have there? I take away y from 4y, that's going to leave me with 3y. The z's are going to go, and I'm going to take away 2 from minus 17, that's going to leave me with minus 15. And so y is going to equal minus 5. Having got that statement, I can go and substitute y is equal to minus 5 into equation D, in which case I've got minus 5 plus z is equal to minus 2. And from that I can say that z must equal 3. So I've now picked up a value of y, I've picked up a value of z. All I have to do now is to go back to one of the original equations, and the simplest of those original equations was equation A. And equation A looked like this. It said x plus y plus 2z equals 6. And I put in the values that I know. I don't know what x is, but I know that y is minus 5. I know that z is 3, so I've got 2 lots of 3 equals 6. And if I solve that, I'm going to come up with the fact that x is equal to 5. And so my solution of x, y, and z is going to be this. X we said is 5, y we say is minus 5, and z we said was 3. And so here we have an algebraic solution to this problem. We can figure out what x, y, and z are by working through this algebraically. Now, we're going to do, and I'm going to do another video shortly that's going to show you how we can think of this problem graphically as well. So how we'd go about solving this by drawing graphs. I'm also going to look at it and show you how we'd go about it using a graphical calculator. So there are two things to look forward to. I'm sure you're excited. Great, well that's all for now. Goodbye.